Welcome to the section 3.2 lecture video. We're going to start out this section with some prerequisite work. So this is actually in your prerequisite packet if you have that at home, but we're going to do it here in section 3.2 just for a little bit of ease for the video. So if dividend p of x and the divisor d of x are polynomials such that d of x does not equal 0, then there exists unique polynomials, the quotient q of x and the remainder r of x, such that p of x equals q of x times r of x plus d of x, where r of x does not equal 0, or the degree of r of x is less than the degree of d of x. So to divide polynomials simply means to look for these pieces. So first of all, if we're dividing monomials, that is, or dividing by a monomial, so we're dividing so that one of the terms is a single term polynomial on the right side of the division side, or the bottom of the fraction bar for using that notation, then we can just use the distributive property to do this division. So 6x cubed minus 9x squared is the same thing as 6x cubed divided by 3x squared minus 9x squared divided by 3x squared. And then we can simply simplify using our polynomial power rules. So we take 6 divided by 3 is 2. X to the third divided by x squared is x to the 3 minus 1, which is 3 minus 2, which is the x to the first power. And then that's minus 9 divided by 3 is 3. X squared divided by x squared, you subtract, is x to the 0. And then we can simplify that to 2x minus 3. Because remember, x to the first power is just x. X to the 0 power is 1. So 1 times negative 3 is negative 3. The same is true if we have it written as a fraction in a fraction bar like this. So in this case, we'd have negative x squared over x plus x over x minus 1 over x. So in this case, we'd get negative x plus 1 minus 1 over x. So now in this case, you can see the different pieces of the answer. So here, this is the quotient q of x, and this piece here is the remainder term, r of x. And notice that r of x is divided by the divisor. So this right here, this number 1, is the remainder. So notice up here, the remainder is 0. This term here would be the remainder. We didn't write it because it was 0, but it would have a remainder of 0. So at this point, go and pause the video for a moment, try the last two, and then when you're ready, start the video up again and we'll go through them. Okay, so the first one, this is just negative 24y to the 12th over 8y to the 3rd. So we divide negative 24 by 8, which is negative 3, and we subtract the exponents on the y's, so y to the 9th. Same idea for the last one. We just break it into two fractions. So 2x squared over x squared plus 1 over x squared. 2 divided by 1 is 2. X squared divided by x squared is 1. So 2x squared divided by x squared is just 2 plus 1 over x squared. Okay, and so that's the idea when one of your terms is a monomial, or when the divisor is a monomial. If that is not the case, then we need to use long division or synthetic division, which is another version of long division. So to divide a polynomial, I have written here use long division for each one of these. So we'll try long division on this page, and then maybe on the next page we'll talk about synthetic division. So long division works just like it does with numbers, except you want to include placeholder values where you have terms that are missing. So in this case, if we look at this first one, we're going to take b to the 6 plus 8 divided by b squared plus 2. So if you remember your long division, b squared plus 2 goes out here on the outside of this bar. And then inside, I'm going to put b to the 6 plus 8. But when you're doing this long division, you need to have a term for every degree in that polynomial, even the ones that aren't written. So we're going to write this as b to the 6th plus 0, b to the 5th plus 0, b to the 4th plus 0b to the third plus 0b squared plus 0b plus 8. Okay? And the way long division works, like if I give you an example over here with some numbers, like if I try to divide 7 into 93, what I do is I ask myself, what could I multiply 7 by to get 9? Or to get a number that's less than 9? In this case, that number would be 1. And 7 times 1 is 7, so we multiply those together, and then we subtract. So we take 9 minus 7 is 2, and I bring down the 3. And then I ask myself the same question too. What can I multiply 7 by to get a number that's less than or equal to 23 and as large as possible? Well, the answer to that is 3. So we multiply 3 times 7 is 21, and then I subtract. And when I get done, that's the remainder, okay, because I'm out of numbers to bring down. So the idea is the same for long division. What could I multiply b squared by to get b to the 6th? And the answer to that is b to the 4th. So what we do is we multiply b to the 4th times b squared plus 2. So b to the 4th times b squared is b to the 6th, and b to the 4th times 2 is 2b to the 4th. And I put that under its like term. And now we subtract. Okay? So I take b to the 6th minus b to the 6th, and those cancel. And I take 0 minus 2b to the 4th, which is negative 2b to the 4th. Okay? And then we move on to the next term. So we do that again. So what do I need to multiply b squared by to get negative 2b to the 4th? And the answer to that is negative 2b squared. So I subtract negative 2b squared up here on top, and then I multiply negative 2b squared by b squared, and I get negative 2b to the 4th. And then I multiply negative 2b squared times positive 2, which is negative 4b squared. And I'll bring down these terms that I need to use here. Okay, and we subtract. So negative 2b to the 4th minus 2b to the 4th becomes positive 2b to the 4th. Those cancel. 0b cubed plus nothing is still just 0, so I don't need that. And 0b squared minus negative 4b squared becomes 0b squared plus 4b squared, so that becomes positive 4b squared. And now we ask ourselves, what do I need to multiply b squared by to get 4b squared? And the answer to that is 4. So we multiply 4 times b squared, and we get 4b squared. And then we multiply 4 times 2, and we get 8. And we bring down the last two terms here. And once again, we subtract. So negative 4b squared minus 4b squared cancels. 8 minus positive 8 is 0 as well. And so we get a remainder of 0. So that means it divided in evenly. So this up here is our answer by itself. Okay, and so that's the idea. So let's try another one using long division. So the next one, x to the 4th goes on the outside. X plus 4, sorry, not x to the 4th. X plus 4 goes on the outside. And inside we put x cubed plus 3x squared minus 3x plus 4. And notice in this case, I didn't need any placeholders. Okay, because I got all the degrees, 3, 2, 1, 0 on the inside of that division. So now we do the same thing we did above. We ask ourselves, what do I need to multiply x by to get x cubed? And the answer to that is x squared. So we multiply x times x squared, and we get x cubed. We multiply 4 times x squared, and we get positive 4x squared. And then we subtract. So 3x squared minus 4x squared is negative x squared. So then we multiply, what do I have to multiply x by to get negative x squared? And the answer to that is negative x. So negative x times negative x is positive x is negative x squared. Negative x times 4 is negative 4x. And then once again we subtract. So minus a negative, this becomes positive, and they cancel. Negative 3 plus 4x becomes x. Sorry, that's not correct. Oh yeah, no, plus 4x becomes x. That is correct. And then we can bring down this 4. And we ask again, x times what gives us x? The answer is 1. So we put a plus 1. 1 times x is x, 1 times 4 is 4, and when you take something minus itself, you get 0. So this one is the answer. Okay? Now, what we really want to be able to do for the most part is we don't necessarily need to know how to do long division. What we'd really like to be able to do is do something called synthetic division. So when we do synthetic division, we'll get to that in a second. So let's go ahead and practice long. Why don't you all take a moment, pause the video, and try practicing these two. And when you're done practicing, you can play the video again, and we'll go through them. Okay, so now that you've had a chance to try these, we can work through them. So we've got x minus 3 and x squared minus x minus 9. So what do you have to multiply x by to get x squared? The answer is x. So x times x is x. X times negative 3 is negative 3x. Subtract. So x squared minus x squared is 0. The negative x minus 3x. This becomes plus 3x. So negative x plus 3x is 2x minus 9. What do we have to multiply x by to get 2x? The answer is 2. 2 times x is 2x. 2 times negative 3 is negative 6. Negative 2x minus 2x is 0. Negative 9 minus a negative 6 becomes negative 9 plus 6, which is negative 3. And so for this one, we end up with is x plus 2 minus a remainder of 3 over our divisor. So that's how we put the remainder into our answer. Or if they ask us what the remainder is, we would just say negative 3. Okay, so this is the remainder. And then the last one, we do set it up. So x plus 1, and inside goes x squared plus 4x plus 5. So what do we need to multiply x by to get x squared? The answer again is x. X times x is x squared. X times 1 is 1x. Subtract x squared minus x squared is 0. 4x minus 1x is 3x. What do we have to multiply x by to get 3? The answer is 3. 3 times x is 3x. 3 times 1 is 3. And we subtract 3x minus 3x is 0. 5 minus 3 is 2. So this one, we get a remainder of positive 2. So this would be plus 2 over x plus 1. Okay, so that's how you do long division. Now, what we'd really like is a quicker way to deal with the ones we're actually going to need to use, and that's what's called synthetic division. So, if we flip over to the next page, we can talk about synthetic division a little bit. So, the key with synthetic division is it's a shorthand way to deal with the terms that we're dividing by. So what we do is we set it up like this. We've got a box that's half open, and then we skip a line, and then we draw a horizontal line. And in the box, we're going to put this term, the opposite of that term, and we call this C. Okay, so this number, the opposite of it goes in here. So in this case, the number we would put in there is a positive 9. Then to the right of that go the terms of the polynomial that's being divided. And it goes from, in this case, we get the x squared coefficient, the plus, then we'd write the x coefficient, and then we're going to write the constant coefficient. If we skip over any of those, we still need to put in a placeholder. So this one, in this case, though, what it would look like would be 1, negative 3, and negative 54. And then what we do to do the division is we add down and then multiply by the number in the box. So this one would be 1 plus nothing is 1. Then we take 9 times 1, and that's 9. Then we add down, and then the multiplied number goes here. So then we take negative 3 plus 9 is 6. We multiply by 9, and that goes in the next column. So 9 times 6 is 54, and then negative 54 plus 54 is 0. And then we can add a little vertical line. So what happened here is we get the remainder is the thing to the right of the line. So the last one's the remainder. Then we have the constant term. Then we have the x term. Then we would have the x squared term, and so on. So in this case, the answer is 1x plus 6, which would be just x plus 6. And so that's the idea behind synthetic division. So in the next one, in the box would go the opposite of 2, which is -2. And then to the right of the box goes the coefficient of these terms. So that would be 3, -1, and 4. And then we add down and then multiply by the number in the box. So 3 plus nothing is 3. -2 times 3 is -6. -1 plus -6 is -7. -2 times -7 is 14. 4 plus 14 is 18. And so once again, we've got the remainder on the far right, then the constant term, then the x term. So this would be the coefficients for those. So this would be 3x minus 7 with a remainder of 18, which we can write as plus 18 over x plus 2. Okay, so that's the idea. So let's do one more together, and then I'll have you all try one. So for the next one, in the box goes the opposite of -1, which is +1, and then the coefficients of this go to the right. So we've got -4 on the x squared term. There is no x term, so I put a 0, and then the constant term is 1. So just like with long division, anytime we skip over a degree, we put a 0. So then we add down, so -4 plus nothing is -4. 1 times -4 is -4. 0 plus -4 is -4. 1 times -4 is -4. 1 plus -4 is -3. And so these are the coefficients starting with the remainder on the far right. So this one would be -4x minus 4 minus 3 over x minus 1. Okay, so go ahead and pause the video for a moment. Try the last one, and when you're ready, go ahead and hit play, and we'll go through the last one together. So for this last one, it was written in a slightly different format, but here's the number that goes in the box, right? The one that's doing the dividing. So in this case, the opposite of -2 is +2. And then the coefficients are 1, -2, and 1. Then we add down 1 plus nothing is 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. So in this case, we get x squared plus 0x plus 1 over x minus 2, or simplified, that would just be x squared plus 1 over x minus 2. Okay, so that's the idea of synthetic division. So that's the review we needed to do at this point in this section. Now, what we're going to use this for is part of trying to figure out what are the zeros of a polynomial function. So if y equals p of x is a polynomial function, then a value of x that satisfies p of x equals 0 is called a zero of the polynomial function. So basically a zero is any number where that makes the polynomial 0. So it's any x value you could plug in to make the polynomial 0. So one of the theorems we need to go along with this is that if r is the remainder when a polynomial p of x is divided by x minus c, then r equals p of c. So the remainder is the same as what you would get if you do the division. The remainder is the same thing as you would get if you would plug the number into the function. So what we're saying is if I did division of these two polynomials, and I could do it using synthetic division, so in the box I would put the opposite of -3, which is 3, and to the right of that I would put the coefficient, so I've got a -4, 5, I skip over w, so I put a 0, and then -7. And so if we do synthetic division like we were doing on the previous page, -4 plus nothing is -4, then I multiply by 3, 3 times -4 is -12, then we add it down again, so 5 plus -12 is -7, 3 times -7 is -21, 0 plus -21 is -21, 3 times -21 is -63, and -70 plus -63 is -70. Negative 7 plus negative 63 is negative 70. So this number, the remainder, should be p of 3 if I plug that into the original function. So we could try that real quick. So if we wanted to use our ClassCalc app for that, we could plug in negative 4 times negative 3 to the third power. And then it was plus 5 times negative 3 squared minus 7. Oh, I put in the wrong number. It shouldn't be negative 3. It's positive 3. Sorry. If we plug in positive 3, we should get negative 70. And you can see that's exactly what we got. So this does work. Okay, so the remainder theorem is true. That if you do synthetic division, it's the same thing as plugging that number into the polynomial. And we'll talk about why that's useful here in a little bit. So let's just practice this idea again moving on. So if I plug in negative 3, if I do negative 3 here, so it's the opposite of 3, which is negative 3, and then my coefficients are 4, 3. I skip over h squared, so 0. The coefficient on h is 1, and the constant is negative 5. Add down 1 plus nothing is 1. Multiply by negative 3. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. 1 plus 0 is 1. Negative 3 times 1 is negative 3. Negative 5 plus negative 3 is negative 8. So P of negative 3 here would equal negative 8. Now, the other thing we should notice before I have you all try them, is not only are we getting, finding this value, we're also doing division. So the quotient for this first one would be negative 4w squared minus 7w minus 21 minus 70 over w minus 3 would be the solution to that division. And over here, we would get h to the third plus 1 minus 8 over h plus 3. So notice, I don't have an, if we write what these should have been, this is the remainder on the far right, then the constant, then h squared, and then h cubed. So I did not have an h squared or an h because their coefficients were 0. And so this would be that written out. Okay, so take a moment, pause the video, and try doing synthetic division for these other two and identifying what value you get when you plug the numbers in. Okay, so now that you've had a chance to try these two videos, these two problems, let's go ahead and work through them together. So the opposite of 1/3 is negative 1/3. And then our coefficients are negative 3, negative 1, negative 3, and negative 1. We add down negative 3 plus 0 is negative 3. Negative 3 times negative 1/3 is 1. Negative 1 plus 1 is 0. Negative 3 times 0 is 0. Negative 3 plus 0 is negative 3. Negative 3, 1/3 times negative 3 is 1. Negative 1 plus 1 is 0. So in this case, P of negative 1/3 equals 0. So that means, based on the definition at the top, that negative 1/3 is a 0 of the polynomial. And that's going to be a really useful fact for us moving forward later. Okay, and then for the second one, we could plug in 2. So 2 goes in the box, and then we've got x to the fourth is 1, x to the third isn't there, so that's a 0. X squared isn't there, so that's a 0, and x isn't there, so that's a 0. And then we've got our constant term, negative 16. So add down 1 plus nothing is 1, 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 0 plus 4 is 4, 2 times 4 is 8, 0 plus 8 is 8, 2 times 8 is 16, negative 16 plus 16 is 0. And so P of 2 equals 0. So that means 2 is a 0 of the polynomial. Okay. Now an interesting point is that also means that these are factors. X minus 2 is a factor of x to the fourth minus 16, and so is b plus 1/3. So those are going to also be used. This has factored our polynomial, which is something we talked about doing previously. So for example, if I talk about this one, I can use my result here to say that x to the fourth minus 16 factors as x minus 2 times my quotient, which would be x to the third plus 2x squared plus 4x plus 8. So not only do we find out that 2 is a remainder, 2 is a zero of the function, we've also been able to factor the polynomial in a way that could be useful to us. Okay? So that's the factor theorem that's here at the bottom. So what we're trying to do is find all the zeros of the polynomial. And one of the things we just learned how to do was we learned how to find out if something is a zero. If we do synthetic division with it and we get a remainder of 0, then it is a 0. We've also talked about the fact that if we find 0, that actually factors the polynomial as well. The key is, how do I figure out what numbers to try and do synthetic division with, right? There's not necessarily an easy way to do that. So there's two theorems here that are really important. One is, if y equals p of x is a polynomial function of positive degree, then y equals p of x has at least one 0 in the set of complex numbers. So when we go to look for zeros, it's not a fool's errand. Some of them exist for sure. And then this second one, the rational zero theorem, says if my polynomial looks like this term here, this thing here, is a polynomial function with integral coefficients, and p divided by q is a rational function of f of x, then p is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. So we've got this term p, we've got both of these, we've got this idea that if this is a factor, then the top of it is a factor. If this is a rational zero, p divided by q, then p is a factor of a sub n, and the bottom of that, q, is a factor of the constant term. Sorry, I got that backwards. P is a factor of the constant term, and q is a factor of the leading coefficient. So what that means is I can get a list of possible zeros by looking for all the things that look like p divided by q. So the way we do that is we list the factors of a sub 0. And in this case, a sub 0 is the constant term, so that's 2. So the factors of 2 are plus or minus 1 and 2. And then we list the factors of a sub n, the leading coefficient. And in this case, that's 18. And the factors of 18 are plus or minus 1, 2, 3, 6, 9, and 18. And so now all of our possible rational zeros will be a number from, so these are my possible p's, and these are my possible q's. So all of them will look like p divided by q. So if I have a rational zero, it will be in the list I'm about to make where I take p divided by q. So what I do is I do plus or minus all of the numbers from list p divided by all the numbers in list q. So I'll start with the first number in the first list, 1, and I'll divide it by all the numbers in the second list. So 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 6, 1 divided by 9, and 1 divided by 18. And then I'll do the same thing with 2. So now I'll start with 2. So 2 divided by 1, 2 divided by 2, 2 divided by 3, 2 divided by 6, 2 divided by 9, and 2 divided by 18. And then we simplify those options. So 1 divided by 1 is 1, 1 half, 1 third, 1 sixth, 1 ninth, 1 18th. 2 divided by 1 is 2. 2 divided by 2 is 1, which I already have, so I don't write it again. 2 divided by 3 can't be reduced. 2 divided by 6 is 1 third, which is already in the list. 2 ninths. And then last but not least, 2 divided by 18 is 1 ninth, which is already in the list. So here's my list of rational zeros. Okay, so these are all my possible rational zeros. And in this list, because of the plus or minus, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 options multiplied by 2. So there's actually 18 options. And so what I would do now, if I don't have a graphing calculator, is I would go ahead and start doing synthetic division with each one of those until I find ones that have a remainder of 0. Okay? So let's try this again for the second one. So we start with our factors of a sub 0. In this case, the constant term is 5, so its factors are plus or minus 1 and 5. And then we do the factors of a sub n, which is 6. So that's plus or minus 1, 2, 3, and 6. And then our possible rational zeros, which I'm going to call PRZ, would be all the things from the first list divided by all the things in the second list. So 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 6, and then 5 divided by 1, 5 divided by 2, 5 divided by 3, and 5 divided by 6. And then we can simplify those if possible. So 1, 1/2, 1/3, 1/6, 5, 5/2, 5/3, and 5/6. And for now, that's all we're trying to do, is find this list. Okay? So go ahead and flip over to the next page and try doing the same thing for these. So find all the possible rational zeros from this list. Okay, so you pause the video if you haven't done so already and try these. Okay, so now that you've given these a try, let's go ahead and walk through them. So the factors of a naught, which is 3, are plus or minus 1 and 3. And then the factors of a n, which is 1, are plus or minus 1. So our possible rational zeros are plus or minus 1 divided by 1 and 3 divided by 1, which are just plus or minus 1 and 3. So we get a much smaller list in that case because 1 and 3 don't have very many factors. And then for the last one, factors of a naught is 6. So the factors are plus or minus 1, 2, 3, and 6. And the factors of a n, which is 4, are plus or minus 1, 2, and 4. So possible rational zeros are plus or minus 1 divided by 1, 1 divided by 2, 1 divided by 4, 2 divided by 1, 2 divided by 2 is already in the list, 2 divided by 4 is already in the list, 3 divided by 1, 3 divided by 2, 3 divided by 4, and then 6 divided by 1. 6 divided by 2 is 3, which is already in the list, and 6 divided by 4 is 3/2, which is already in the list. So there are all my possible rational zeros for this one. Okay, so that's the idea. So if I wanted so there's one more thing we want to practice before we combine this all together. And that's called using division to factor completely. So if you are given one of the factors of a polynomial, then you can use division to find other factors or to see if a polynomial is a factor of another polynomial. If a polynomial is a factor of another polynomial, then the remainder will be 0. Remember to check the new factor to see if they can be factored more. So the idea here is, what I could do is to factor this bigger polynomial, I can check and see if the smaller polynomial is a factor by using synthetic division. So the opposite of -2 is 2. Then I put in 4, 4, -25, -1, and 6, the coefficients of that, and I do division. So 4 plus nothing is 4. 4 times 4 is 8. 4 plus 4 is 12. 4 times 12 is 24. -1, -25 plus 4 is -1, sorry. 2 times -1 is -2. -2 plus -1 is -3. 2 times -3 is -6. 6 divided by -6 is 0. So that means that this original polynomial factors as x minus 2 times 4x cubed plus 12x squared minus x minus 3. And so now we factored out one of the polynomials by using division, and we can continue to factor from there. So if I wanted to, I could factor this polynomial by grouping. What do the first two terms have in common? Well, they have a 4x squared in common, right? So I can factor out 4x squared, and that leaves me with x plus 3. And then if I factor out a -1 from over here, that leaves me with x plus 3. And now I can factor out the x plus 3. Sorry, I accidentally wrote that wrong. X plus 3 from both of those, and I'm left with 4x squared from the first term minus 1. And now I can actually factor this even further by looking at these last two terms. So the last two terms there are both perfect squares, so I can do the factor the difference of squares. So 4x squared minus 1 factors as 2x minus 1 times 2x plus 1. And so we use the division to get us starting, and then we can continue to factor from there. Okay, so let's try one more together. So the opposite of 1 is negative 1. And then our coefficients are 1, 0, negative 13, and negative 12. 1 plus nothing is 1. Negative 1 times negative 1 is... Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. Negative 13 plus 1 is negative 12. Negative 1 times negative 12 is 12. Negative 12 plus 12 is 0. So this one factors as x plus 1 times x squared minus x minus 12. And now we can try to factor the second term even more. So we want to look for two numbers that multiply together to get negative 12 and add to get negative 1. So we can look at the factors of negative 12, which are 1 and let me give myself a little bit more room than that. So I'm going to do it. I'll just write it in the middle. So negative 12. So we've got 1 plus negative 12, which is negative 11. 2 plus negative 6, which is negative 4. And 3 plus negative 4, which is negative 1. So this one works. So this factors as x plus 1, which is left over from up here, times x plus 3 times x minus 4. Okay, and so that's the idea. So go ahead and pause the video for a moment and try doing this last one. First by doing division and then factoring what's left over. Okay, so now that you've had a chance to try that one, let's go through it together. So the opposite of negative 1 is 1. Coefficients of the polynomial are 1, 4, 1, negative 6. Do synthetic division, so 1 plus 0 is 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 1 plus 5 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. So that factored as x minus 1 times x squared plus 5x plus 6. And now we can factor what's left over using the same idea as above. We need two numbers that multiply to get 6 and add to get 5. So 1 plus 6 equals 7. 2 plus 3 equals 5. So this one works. So this factors as x minus 1 times x plus 2 times x plus 3. Okay, so that's the idea. So now we can put this all together to try and find all the zeros of a polynomial function. So if we wanted to do one of these without using any technology, we could try that. So the way that would work is you would start by finding all the possible rational zeros. So in this case, we could, so we could start by finding all the possible rational zeros. So those rational zeros would be using these two terms. So we do factors of the last term divided by factors of the first term. So 1 factor of 9 is 1. So factors of 2 are 1 and 2. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. Then another factor of negative 9 is 3. 3 divided by 1 is 3. 3 divided by 2 is 3 over 2. And then the last factor of 9 is 9. 9 divided by 1 is 9. 9 divided by 2 is 9/2. So we've got a list of about 12 possible rational zeros. And so now what we do is we just start doing division, synthetic division. So we've got, we can just start going through the list. So I could try 1. So 2 plus nothing is 2. 2 times 1 is 2. 5 plus 2 is 7. 1 times 7 is 7. 3 plus 7 is 10. 10 times 1 is 10. 15 plus 10 is 25. 1 times 25 is 25. Add those together and you get 16. So this is not 0. So 1 didn't work. Okay, so then we keep going. So we could do 1/2. So we've got 2, 5, 3, 15, negative 9. So we've got 1/2 times 2 is 2 plus nothing is 2. 1/2 times 2 is 1. 5 plus 1 is 6. 1/2 times 6 is 3. 3 plus 3 is 6. 1/2 of 6 is 3. 15 plus 3 is 18. 1/2 times 18 is 9. Negative 9 plus 9 is 0. So that means this is a 0. Okay? So that means this thing factors as v minus 1/2, because remember, it's the opposite of the number in there. So v minus 1/2 times 2v cubed plus 6v squared plus 6v plus 18. And we're trying to find the zeros of this, so we're setting this polynomial equal to 0 and solving. Now, you could keep going through this list of possible rational zeros to see if you find any more, or you could try factoring this. So let's try factoring it by grouping like we did on the previous page. So what do the first two have in common? Well, they have a 2v squared. So we get 2v squared times v plus 3. And then what do these two have in common? A 6. So we factor that out and we get v plus 3. And now we can factor out the v plus 3. So this is v minus 1/2 times v plus 3 times 2v squared plus 6. And now we have a bunch of stuff multiplied together to get 0. And in order for that whole thing to be 0, at least one of them needs to be 0. So this would be v minus 1/2 equals 0. V plus 3 equals 0. And 2v squared plus 6 equals 0. And these are all things we know how to solve, because the first two are linear and the last one's quadratic. So we can solve the first one by adding 1/2 to both sides. So those cancel and leave me with v equals 1/2. Here I subtract 3 from both sides, and I get v equals negative 3. And then the last one I can subtract 6, which is 2v squared equals negative 6. Divide by 2 to get v squared equals negative 3. And then do the square root of both sides. So v equals plus or minus the square root of negative 3, which it's the square root of a negative number. So that's v equals plus or minus I root 3. And so there are 4 zeros of this polynomial function. Now, zeros are what happens when the function equals 0. So that's the same thing as saying so zeros are when p of x equals 0, which is the same thing as saying when y equals 0. Well, another name for something for a real thing where y equals 0 is called a x-intercept. So real zeros will be x-intercepts. So there's a really nice way to use technology to help you find all these zeros of the polynomial. And the way you do that is you graph the equation. So let's go ahead and graph this first one, which I'll admit I did not look at closely enough to be able to do that. I'm actually real quick going to bring this up in another slide so I can look at it while I'm working on this. Okay, yeah, so we're going to graph y equals, so go to your graphing function, and we're going to graph y equals 15 x cubed minus 37 x squared plus 44x minus 14. And if we do that and we click on the graph, we should get an x-intercept. And that x-intercept is 0.466667. Okay? Which you may need to use your calculator to change that. We can zoom out a little too to make sure there aren't any others. And yeah, there aren't any others. But you may need to use your calculator to change that for you. So let's see if that works on this calculator. So if I type in 0.4666666667, let's see if it'll change that into a fraction for me. Yep. So it changes that. It tells me it's 7/15. So from the graph, we get that 7/15, 0 is an x-intercept. So this means that 7/15 is a 0 of the polynomial. Okay, so one of our zeros is 7/15. So now we can do what we did on the last page and what we tried to do up here. Instead of having to go through the possible real zeros and try a bunch of them, I can take that 1 and do synthetic division. So 7/15, and then I've got 15, negative 37, 44, and negative 14. And let's do synthetic division. So 15 plus nothing is 15. 7/15 times 15 is 7. Negative 37 plus 7 is negative 30. 7/15 times negative 30 is going to be negative 14. 44 plus negative 14 is 30. 7/15 times 30 is 14. Negative 14 plus 14 is 0. And remember, this 0 is what we expect to get if it's a 0. So that's good, right? So now that leaves us with, we've got x minus 7/15, and we've got 15x squared minus 30x plus 30 equal, and then the whole thing equals 0. And this thing is quadratic, and we know how to solve quadratic. So this will be x minus 7/15 equals 0, and 15x squared minus 30x plus 30 equals 0. Okay, so the one on the left, add 7/15 to both sides, right? And we get the 0 we expect, which is 7/15. And then solve this one. And you could start by dividing both sides by 15. So it's x squared minus 2x plus 2 equals 0. And then use the quadratic formula. So this is x equals the opposite of b. So 2 plus or minus the square root of negative 2 squared minus 4 times negative 2 times 2. Whoops, not negative 2 in the middle there. That should be a 1. 4 times 1 times 2 over 2 times 1. So we simplify underneath the square root. So this is 2 plus or minus 4 minus 8. So that's going to be negative 4. So the square root of negative 4 over 2. The square root of negative 4, well, it's negative, so it's going to have an I. And the square root of 4 is 2, so it's 2i over 2. And then we can simplify. So 2 divided by 2 is 1. 2i divided by 2 is I. So the other two are imaginary, 1 plus or minus I. Okay, so let's go and try. I've got, I think, 2 more pages of these. So let's go and try a couple more together, and then I'll have you all try a couple, and then we'll be done with this lecture video. So the next one, start out exactly the same way, right? So go to your calculator app and graph it. Okay, so if we go in here, go to the graphing function, and we graph y equals x cubed minus 5x squared minus 12x plus 36. And we look, we get 3 x-intercepts. So we get negative 3, 0, 2, 0, and 6, 0. Okay, so negative 3, 0, 2, 0, and 6, 0. And so what you can do is that should be, so now what we can do is we can do synthetic division with those and see what factors, if any, we have left. So I can start with negative 3, and my coefficients are 1, negative 5, negative 12, and 36. Okay, so that's 1 plus nothing is 1. Negative 3 times 1 is negative 3. Negative 5 plus negative 3 is negative 8. Negative 3 times negative 8 is 24. Negative 12 plus 24 is 12. Negative 3 times 12 is negative 36. 36 plus negative 36 is 0. So we factored out this is x plus 3 times x squared minus 8x plus 12. And now 2 and 6 must be linked to factors of what's left over in here. So those coefficients are already written here. So now I can just go ahead and from that answer factor out the 2 by doing synthetic division again. So 1 plus nothing is 1. 2 times 1 is 2. Negative 8 plus 2 is negative 6. 2 times negative 6 is negative 12. 12 plus negative 12 is 0. And then we can do 6. Okay, so 1 plus nothing is 1. 6 times 1 is 6. Negative 6 plus 6 is 0. Okay? And so what we end up with in the end is a factor of 1. So this is x plus 3 times x minus 2 times x minus 6 times 1 equals 0. And is there anything else left to solve? No, because I know what these answers are. So I get x equals negative 3, 2, and 6. So the nice thing about the graph 2 is sometimes it's going to be super quick and easy if all of the zeros are already x-intercept. Okay, so let's try one more together. So same idea. All right, so I'm just going to graph it. So we go to the graph, and we graph x to the third plus 4x squared plus 4x plus 3. And in this case, we see we get 1 x-intercept, negative 3 comma 0. So we can go back, and we've got negative 3 comma 0. So we start the same way we did up here, right? We're going to do negative 3 in synthetic division. So it's 1, 4, 4, 3. So 1 plus nothing is 1. Negative 3 times 1 is negative 3. 4 plus negative 3 is 1. Negative 3 times 1 is negative 3. 4 plus negative 3 is 1. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. And so now we factored this as x plus 3 times x squared plus x plus 1 equals 0. And we solve both of those. So the one on the left, subtract 3, and we get x equals negative 3, which is exactly what we expected from the graph. And the one on the right, we need to use the quadratic formula. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 all over 2 times 1. So x equals negative 1 plus or minus the square root of 1 minus 4, which is negative 3, over 2. So that's x equals negative 1 plus or minus I root 3 over 2. And then if we want, we can divide both pieces by 2 and write it as negative 1/2 plus or minus root 3 over 2i. And there are other 2 zeros. So at this point, you can flip to the next page, pause the video for a moment, and try these two problems. So graph them and then use synthetic division and factoring to find any other zeros. Okay, so now that you've had a chance to do these, let's go ahead and do them together. So I'm going to go to my graphing calculator, and I'm just going to go ahead and graph both of these at once. So I've got y, and remember, I didn't say this before, but you have to replace anything that's not an x with x. So this needs to be 4x cubed minus 10x squared plus 4x plus 5. And then the other one, we'll go ahead and graph it as well. Y equals 18x cubed minus 9x squared minus 5x plus 2. Okay, so interesting, they both share one right here, which is kind of hard to see, so let me get rid of this one. So for the first graph, we get negative 0.5, which hopefully we all recognize as negative 1/2. And then for the other one, we get negative 0.5, negative 1/2, 0.3 repeating, which is 1/3, and 0.6667, which is 2/3. So back to our notes. For the first one here, we got negative 1/2 comma 0. And for the second one, we got negative 1/2 comma 0, 1/3 comma 0, and 2/3 comma 0. Okay, and so now we go ahead and do synthetic division. So for the first one, we've got negative 1/2, and then our coefficients are 4, negative 10, 4, 5. So I do my synthetic division. 4 plus nothing is 4. Negative 1/2 times 4 is negative 2. Negative 12 plus negative 2 is, negative 10 plus negative 2 is negative 12. Negative 1/2 times negative 12 is 6. 4 plus 6 is 10. 10 times negative 1/2 is negative 5. 5 plus negative 5 is 0. And so we've got x plus 1/2 times 4x squared minus 12x plus 10 equals 0. Set them both equal to 0. One on the left, subtract 1/2. And you get x equals negative 1/2. One on the right, you're going to have to use the quadratic formula. Okay, so this would be x equals 12 plus or minus the square root negative 12 squared minus 4 times 10 all over 2 times 4. So this is x equals 12 plus or minus the square root of 144 minus 160. 144 minus 160, which is negative 16 over 8. So x equals 12 plus or minus the square root of negative 16 is 4i over 8, and then we can simplify those. So 12 divided by 8 is 3/2. 4 divided by 8 is 1/2 I. And then on the last one, you found quite a few zeros here, so you might actually be done, but you might want to go ahead and do some deck division to make sure there are no factors left. So start with negative 1/2. So we've got 18, negative 9, negative 5, 2. And do some deck division. So 18 plus nothing is 18. Negative 1/2 times 18 is negative 9. Negative 9 plus negative 9 is negative 18. Negative 18 times 1/2 is 9. 9 plus negative 5 is 4. 4 times negative 1/2 is negative 2. Negative 2 plus 2 is 0. Okay, so that one's good. So then do 1/3. So 18 plus nothing is 18. 18 times 1/3 is 6. Negative 18 plus 6 is negative 12. 1/3 times negative 12 is negative 4. 4 plus negative 4 is 0. And then the last one, 2/3. So 18 plus nothing is 18. 18 times 2/3 is 12. 12 plus negative 12 is 0. So we're left with just the factor 18. So this factors as x minus x plus 1/2 times x minus 1/3 times x minus 2/3 times 18 equals 0. And notice each one of these, we already know what makes them 0. Negative 1/2, 1/3, and 2/3. But 18 can't equal 0, so these are my answers. So x equals negative 1/2, 1/3, and 2/3. Okay, so that's it for finding the zeros of a polynomial. It's really the best way to do it is using the ClassCalc app. As always, if you have any questions about this, feel free to contact me by email, text, or phone. I'll hope all of you will continue to check in with these videos, and hopefully I'll have some virtual office hours coming up.